All right, I had some questions about number 12 from lesson 7. So what do we have here? We want to find the intersection point of a line and a sphere. So I'm going to give myself a sketch of a sphere and make it look 3D. So there we go. There's my sphere. If we jam a line through the sphere, so there, and then I'll use dashed lines to show it passing through, and it pokes out over here. We are going to have an entry and an exit point, so we're predicting 2 solutions. If we end up with 1 solution, all right, that means it just grazed the sphere, so it'd be tangential to the sphere. If we end up with no solution, it means that the sphere and the line are skew, so it means you'd end up with this situation. So from matrices, keep in mind, we know that our possible solutions, so for 2 solutions, we should end up with a squared term. So we should end up with t squared equals a positive number. If it was 1 solution, we would end up with t equals a number. And if it is no solutions, we would end up with 0t equals a number. All right, so that would tell us intersects twice, intersects once, grazes it tangentially, or they're skew. All right, so just something to keep in mind. That's what I got in the back of my head when I'm doing my solution when I go to interpret. So here's the how. I'm going to convert that equation of a line to parametric form. So hopefully you are comfortable doing that. So I'll put the 0 in for argument's sake. Y equals 5 minus 3t. Z equals 3 minus 2t. I know this is the equation of a sphere. This is not taught in Ontario curriculum anymore. Well, not taught, it never was taught in the Ontario curriculum. But x squared, y squared, z squared is a sphere centered at the origin. We want to find the intersection point. So we're just going to do a substitution. What is x equal to? X is equal to t. What's y equal to? Y is 5 minus 3t. And z is 3 minus 2t. So I just substituted the equation of a line into the equation of a sphere. So now we're going to find the scalar multiple of the direction vector. All right, we're looking for the t value because that'll tell us what locations along the line the intersection occurs. Common mistake with this one, you need to FOIL. So we're going to put FOIL underneath these guys, or distributive law, if you never learned what FOIL, the acronym was. So you should end up with 25 minus 30t plus 9t squared. So when you multiply 2 binomials, you always end up with 3 terms. Plus 9 minus 12t plus 4t squared equals 6. Now this is where I've got to be careful collecting my like terms. 1 will give me 10. So I should end up with 14t squared. Now the numbers, negative 30, negative 42. And then constants, I got 25, 34, that's it, plus 34 equals 6. I'm going to solve a quadratic. I have t squared, so it is a quadratic. I'm going to bring that 6 across, 42t, so that is going to be subtraction, which will bring me out to plus 28. That's equal to 0. So now I'm going to do a common factor, just to make things a little bit easier here. So I'm going to pull a 14 out. T squared minus 3t plus 2. That's equal to 0. Oops, hang on, smartboard's gone crazy. Okay. So now I get to factor that, and so fortunately this question, when I look at it, this is going to factor nicely, so I don't have to go to the quadratic formula. 2 numbers that multiply to 2 and add to negative 3. So I'm going to end up with t equals negative 2 t equals t minus 1. So therefore, my scalar values will be positive 1 and positive 2. So it tells me that I have two solutions because I was able to solve for t. And now I'm able to calculate where it occurs or where those occur. So now I gotta go back here and cheat a little bit. Oh, copy that. And move down here. Oops. Paste. So I have the equation in front of me. So for t equals 1, the coordinate will be 1. 5 take away 3 is 2. 3 take away 2 is 1. So there's the first point of intersection. And for t equals 2, I'm going to end up with 0 plus 2 is 2. 5 take away 6 is negative 1. And 3 take away 4 is negative 1. So assuming I was able to do my mental arithmetic properly and not mess up, which has happened before, those will be my 2 points of intersection. So therefore, my 2 points of intersection will be, I love math when you do short forms all the time, 1, 2, 1, and 2, negative 1, negative 1. If you have any other questions, let me know.